We are Team 7 and this is our Technology-Enabled Sustainable Container Homes presentation. The idea of containerized shelters started with emergency shelters in the mid-part of the 20th century. The idea of containerized housing was patented in 1989 by Philip Clark. The current container home trend started in 2006 with the Redondo Beach House, pictured to the right. Additionally, as you can see on the graph, in 2007, interest in container homes started to rise steadily. The industry is an example of sustainable housing and directly competes with apartment homes, modular and mobile homes, and even traditional homes. The benefit of containerized homes is that they are ecologically friendly, use decommissioned shipping containers as the raw material for construction and assembly, and have a shorter cycle time than traditional construction. The need for affordable housing alternatives that give consumers the opportunity to own their own homes is more prominent because of the Great Decoupling, a divide between wage growth and productivity growth that has led to stagnant wages and higher costs of living. Our company, BDLS Services, is the parent company of BDLS Homes. We were founded in 2015 as a startup to create affordable, sustainable shipping container homes that are technologically enabled and fully connected. From top left to bottom right, Brent Plath, David Wolski, Lamont Whitehead, and Saeed Hussein. Now, the current process to build a containerized home is to have the decommissioned shipping containers shipped directly to the job site and then modified on site, with doors, windows, drywall, and the finishing taking place on site. With a traditional house, the frame is built on site and walls erected. This process was very similar with the shipping containers acting as the frame and exterior walls and roof of the home. This process provided an opportunity to identify ways in which the process of fabrication could be improved and costs reduced using containers. Stepping away from the traditional construction methods in building a house and looking more at how mobile and modular homes are built, a prefabrication process is to be implemented to expedite assembly and create a more efficient process of home construction. Instead of the shipping containers being fabricated on site, they will be prefabricated off site and transported to the job site, at which point they will only need to be bolted together. This reduces the cycle time of construction and provides cost benefits in the form of construction savings as well as process improvements. The key transformations beyond the prefabrication model are the inclusion of the Internet of Things connectivity to home appliances, transforming these homes into smart homes. With the data collected from these devices, it allows us to create a new revenue stream in monitoring and maintaining the technology portion of our homes. In partnership with an Internet of Things platform provider, we will be able to provide homeowners a means to monitor their own homes, as well as allow our company to collect the non-personal data and create a further revenue stream by partnering with IoT device manufacturers to sell the device data back to them, allowing them to make improvements and modifications based on usage data to their own products. Additionally, another key transformation is that of including solar energy options with all of our homes. The solar lease will provide another source of revenue in the form of solar rebates from the government and solar lease payments from the homeowners. They will not own the systems, instead leasing them directly from us as we will buy the systems from a solar provider that we partner with. This is a very high-level view of our architecture. With the inclusion of an off-site data center, data will be uploaded to the data center directly from the smart container homes through a required internet connection. Either the customer can select their own internet provider or it can be provided by our company for an additional fee, creating another revenue stream. We will be able to remotely connect to the data center through IoT monitoring software through our IoT partner. We will be able to use that data for marketing purposes, preventative maintenance, and to sell that data back to the device manufacturers so that they may make improvements to their devices. Additionally, we will be able to provide homeowners energy statements in order to help them better utilize their smart container home. We did need to make a number of assumptions in order to facilitate an approximation of the costs and revenues. Most importantly, the starting price of our homes will be approximately $100,000. Another assumption we needed to make was the amount of startup capital we would need in order to safely operate under pessimistic, realistic, and optimistic conditions, which is $1 million. We could likely start off with less of an investment, however, for the purposes of explaining the return, this was a good approximation of how to continually operate over 6 years. Each home will consist of at least 5 containers, putting square footage between 1,500 and 1,600 square feet. We also made assumptions on the land value in the Phoenix area, primarily suburban areas. However, the largest assumption we made is that we will be able to secure partnerships to gain bulk pricing with shipping container providers, solar providers, an offsite data center provider, IoT device manufacturers, and IoT platform providers. We've also assumed a 2% increase in cost and 2% increase in home prices, essentially rising concurrently with cost over the next 6 years. We also had to assume that we would work to build 3 additional homes in each successive year, starting with 10 homes in the first year and 25 homes in year 6. Now, a few of the minor assumptions that we made is that we will be including a technology maintenance fee in order to offset data center costs and maintaining the homes, as well as to facilitate upgrades to the network. Another assumption that we made was that price for labor and contractors will be lower through contract bidding, enabling us to select the most value as far as selecting which contractors to work with annually. Now, as far as marketing and sales costs, we also had to assume that that would be more effective when used to market multiple homes instead of marketing for just single homes. And we also did break down the total data center cost to how much it would cost per home based on what we build annually. Now let's take a look at our pessimistic projection. Now, looking at the pessimistic projection, based on the initial $1 million investment, costs and revenue are very close. The calculated internal rate of return is 3.76%, giving a net cash flow of $157,100 after 6 years. Ideally, we would like a net cash flow much larger than that, but again, this is the pessimistic projection. Now, looking at our realistic or most likely projection, there is an improvement in the internal rate of return up to 48.51%, giving a net cash flow over 6 years of $2,918,690, which is a much more attractive figure. Again, based on the initial $1 million investment. Now, looking at our optimistic model, if we are able to secure attractive partnerships with our key partners, we are looking at the potential of a 74.43% internal rate of return with a net cash flow of $4,752,950 over 6 years. In the optimistic and realistic projections, we are no longer burning cash within 4 years. However, in the pessimistic projection, it will take 6 years before we are no longer burning cash. Another assumption we are making is that we are able to complete construction and assembly of one home every 29 days, with delivery of prefabricated containers to the home site to take 1 week, assembly to take 2 weeks, the IoT device installation and testing to take 1 week, and the client moving in on the last day. Now, our key timeliness measures reflect our milestones, with delivery of the home to the customer in 29 days. Again, with the prefabricated container making it to the home site within 1 week, assembly to take an additional 2 weeks, IoT device installation and testing to take an additional week, and the client moving in on the last day. Effectiveness measures will be our ability to increase production by 3 homes annually. Also maintaining lower costs, increased cycle times, differentiation and choice with IoT product options, and to continually grow our revenue while identifying process improvements to keep our costs leveled off as much as possible in the event that the pessimistic projection does ring true in some years. Now, looking back at those projections, the realistic projection shows a consistent increase in revenue while costs level off. However, the pessimistic scenario shows an increase in revenue consistent with the costs. And the optimistic projection shows an increase in revenue while costs remain relatively flat. Now, we want to continually evolve our processes to facilitate increased production. This makes BDLS Homes a smart investment based on projections of the net cash flow and internal rate of return. We also will look for ways to reduce our cycle time and create opportunities for process improvements to build multiple homes concurrently while increasing our market share. Now, while our cycle time does show room for improvement, there is definitely going to be a ceiling in which we can no longer shorten the cycle time of assembly of the container homes, at which point we will look for other processes that we can make more efficient in order to facilitate more homes produced and more customers moving in. Thank you for watching our presentation. We have been Team 7.